I've always thought it was interesting that Australia sits directly next to the most violent volcanic and seismic zone on Earth, the Pacific Ring of Fire. Yet it has zero active volcanoes and experiences minimal earthquakes. Meanwhile, everything around it experiences constant geological activity. Indonesia has frequent eruptions, New Zealand has regular earthquakes, and Japan has both, constantly. But Australia? Almost nothing. So, why did one continent escape while everything surrounding it sits on active plate boundaries? Welcome aboard Arnie's Brain Train. I'm your host, Alex Arnold, and today we're solving that mystery. Now, what exactly is the Ring of Fire, and why did Australia get so lucky? Well, the Ring of Fire is a 25,000-mile horseshoe that produces 90% of the world's earthquakes and 75% of its volcanoes. And sitting in the middle of all of that activity, geologically quiet, is Australia. But quick disclaimer before we dive deeper, because I know how the internet works. You're going to see AI generated images in this video. I use them because I'm not paying licensing fees for stock photos of rocks. If that's a deal breaker for you, the door's right there, no hard feelings. You might also disagree with some of my conclusions or interpretations. That's totally fine too. I'm not running for office or anything. I'm presenting evidence and drawing conclusions based on that evidence. All of my sources are linked below, so check them yourself and form your own opinions. That's literally what I want you to do. This channel is about following the evidence and asking questions that actually matter. We're not here to make people comfortable. We're here to figure out how things actually work. So, with that being said, let's figure out how and why Australia ended up where it did. All aboard. Alright, so to understand why Australia escaped, we first need to understand what creates the Ring of Fire in the first place. The Pacific Ring of Fire stretches from New Zealand up through Indonesia and Japan, across the Aleutian Islands and Alaska, down the west coast of North and South America, and back around. It's a zone of tectonic plate boundaries where the Earth's crust is constantly being destroyed, recycled, and recreated. And in the middle of this activity, and geologically stable, sits Australia. So here's the backstory. For over 30 million years, Australia was welded to Antarctica. When it broke free about 45 million years ago and drifted north, it became one of the most geologically stable continents on Earth, with no active volcanoes and minimal earthquake activity. But while Indonesia to the north experiences regular volcanic eruptions, while New Zealand to the east experiences frequent earthquakes, and while the entire Pacific coastline from Chile to Alaska sits on active plate boundaries, Australia sits happily in the middle of its plate. Now, understanding why this happened helps us understand how the Ring of Fire works, what patterns have emerged over time, and what we can learn from both geological records and thousands of years of human observation. Now, the Ring of Fire exists because of something called subduction. Earth's crust isn't one solid shell. It's broken into massive plates that float on the semi-molten mantle below. These plates are constantly moving, and when they collide, one of three things happens. They crunch together and build mountains, they slide past each other and cause earthquakes, or one plate slides under another and gets recycled back into the mantle. That last one is called subduction. When an oceanic plate, like the Pacific plate, collides with a continental plate or another oceanic plate, the denser oceanic crust gets forced downward. As it descends into the hotter mantle, water trapped in the rock gets released, lowering the melting point of the surrounding rock. This creates magma, which then rises through the crust and erupts as lava from volcanoes. According to the U.S. Geological Survey, the Pacific Plate is currently being subducted beneath at least 7 other major plates, creating multiple subduction zones all around its edges. That's why you get this ring pattern. It's the Pacific Plate basically being consumed on almost all sides. So here's the answer to our title question. Why does Australia survive while everything around it sits on active boundaries? What it really comes down to is position. Australia sits on what geologists call a stable craton, ancient continental crust far from any subduction zones or major fault lines. According to Geoscience Australia, the Australian continent sits in the middle of the Indo-Australian plate, far from active boundaries. When Australia separated from Antarctica about 45 million years ago, it drifted north into a geologically stable position. It's not on a plate boundary, and it's not being subducted. It just sits in the middle of its plate, while the edges, where New Zealand, Indonesia, and Papua New Guinea sit, experience all the activity. So that's the key difference. Australia is positioned in the plate interior. Its neighbors are on the boundaries, where tectonic activity actually occurs. Meanwhile, the Ring of Fire itself isn't just one fault line. It's hundreds of interconnected fault systems, volcanic arcs, and oceanic trenches. When one section becomes active, it can create stress changes in neighboring sections through dynamic stress transfer. The major zones include the Cascadia subduction zone off the Pacific Northwest, capable of magnitude 9 plus earthquakes, the Japanese archipelago, where the Pacific, Philippine, and Eurasian plates all converge, the Tonga Kermadec Trench, one of the deepest parts of the ocean, the Andes volcanic arc, the longest continental volcanic arc on the Earth, and the Indonesian archipelago, home to Krakatoa, Tambora, and dozens of active volcanoes. Each of these zones has produced major eruptions in recorded history. Mount Tambora in 1815 created the year without a summer that caused crop failures across the entire northern hemisphere. Krakatoa in 1883 was heard 3,000 miles away and generated tsunamis that killed over 36,000 people. But even Australia, despite its stability, isn't completely immune. In 1989, a magnitude 5.6 earthquake struck Newcastle, killing 13 people. As a stark reminder that even stable regions can experience seismic events, though at much lower frequency than active plate boundaries. Now that we understand the mechanics, let's talk about how people living on the Ring of Fire have observed and documented these patterns over time. If you're familiar with the channel, whether it's videos about Moses and the Tower of Babel examining how different cultures documented the same events, or lost civilization videos exploring ancient knowledge networks, you know that I always have to look at how ancient cultures preserved accurate information, especially when modern science later confirms it. Geological science and cultural records intersect when we look at indigenous traditions from the Ring of Fire regions. We find detailed observations about volcanic and seismic patterns, information that's proven accurate when it's actually checked against modern geological evidence. These are amazing observational records preserved across generations. The indigenous peoples of the Pacific Northwest, the Cascadia region, have oral traditions describing earthquakes, followed by the ocean retreating before waves destroyed coastal villages. For a long time, Western geologists had no historical record of major earthquakes in this region. Then, in the 1980s and 90s, geologists discovered evidence of a megathrust earthquake that struck the Cascadia subduction zone on January 26, 1700. Magnitude estimated at 8.7 to 9.2. But how could they possibly date this? Well, Japanese historical records documented an orphan tsunami, a tsunami that arrived without any felt earthquake, on that exact date. They ascertained that the wave had traveled across the Pacific Ocean from Cascadia. According to research published in the Journal of Geophysical Research, tree ring analysis of the ghost forests, the trees that were killed by sudden saltwater intrusion, all confirmed the indigenous accounts. The Quileute, Makah, Huayat, and other tribes have preserved accurate information about this event for nearly 300 years through their oral tradition. They knew the pattern. The ground shakes, the ocean pulls back, and a giant wave comes. That knowledge represents observation that was passed down as survival information. The Maori people of New Zealand have detailed oral traditions about specific eruptions, including the Taupo eruption around 232 AD, one of the most violent eruptions in human history. Their traditions describe geological events with enough detail that researchers have used them to help date and understand volcanic sequences in New Zealand. They aren't just Fire Mountain myths and stories. These stories actually contain specific geographical and sequential information. In Japan, cultural frameworks for understanding seismic activity developed over centuries of living on one of the most tectonically active regions on Earth. Historical records and cultural practices reflect sophisticated observation of earthquake patterns, tsunami behavior, and volcanic activity. After major earthquakes in the Edo period, detailed documentation was created that modern seismologists have used today to understand historical seismic sequences. What's significant here is the pattern. Cultures living on the Ring of Fire developed detailed knowledge about geological hazards because observation and memory were survival tools. When we find alignment between these cultural records and modern geological evidence, these traditions can then be seen to preserve real data. Geological records and human observation complement each other. Tree rings, sediment cores, and geological surveys give us physical evidence. Cultural records give us human scale observations of how these events manifested and what warning signs preceded them. Both sources of information are extremely useful. So, that brings us to the present. What does our modern technology and our current research tell us about the Ring of Fire activity today? We now have the technology and global monitoring networks that the ancient cultures didn't have. So, what does current research actually tell us about the Ring of Fire activity? According to the USGS, there is no statistically significant increase in global earthquake frequency over the past century when you account for improved detection technology. We have more seismometers, better data collection, and instant global communication, so we notice more earthquakes, but that doesn't necessarily mean that more are occurring. However, global averages can also mask regional patterns. Research published in Nature Geoscience shows that large earthquakes can influence seismic activity thousands of miles away through dynamic stress transfer. So while the total numbers might be stable, the location and clustering of events can and does change. There's also research examining potential correlations between various factors and earthquake frequency. A 2017 study presented at the Geological Society of America analyzed earthquake data and found correlations between slight decreases in Earth's rotation speed and increases in magnitude 7 plus earthquakes. This research has been highly debated, and it represents ongoing investigation into whether global scale phenomena might influence the seismic patterns. For volcanoes, the Smithsonian Institution's Global Volcanism Program tracks active eruptions worldwide. Typically, 40 to 50 volcanoes are actively erupting at any given time, and that number hasn't changed dramatically in recent decades. Recent major eruptions in the Ring of Fire include Mount Semeru in Indonesia 2021, Tonga's Hunga Tonga Hunga Ha'apai in 2022, one of the largest eruptions in decades, multiple eruptions in the Aleutians, and overall increased activity at various locations in New Zealand, Philippines, Japan, and along the Pacific coastlines. Whether these represent connected events or independent volcanic cycles is an area of active research. Some geophysicists argue that major earthquakes and eruptions can create stress changes that propagate through connected fault systems. Others point out that we're seeing normal volcanic cycles, and improved monitoring simply makes the activity more visible. Here's the real challenge, though. We're trying to understand patterns that unfold over thousands or perhaps millions of years using less than a century of comprehensive global data. Seismographs have only existed since the late 1800s. Global seismic networks only since the 1960s. That's a pretty narrow window for understanding long-term patterns. This is why the Australia comparison matters so much. Australia's position in the middle of a plate experiencing minimal seismic activity gives us a control group of sorts. The Indo-Australian plate is colliding with the Eurasian and Pacific plates. That collision creates the Indonesian volcanic arc and New Zealand's earthquake activity. But the Australian continent sits away from those boundaries. Geography determines geological hazards. Even so, Australia experienced that 1 magnitude 5.6 Newcastle earthquake in 1989, reminding us that the plate interiors aren't perfectly stable, just dramatically more stable than the boundaries. The difference in frequency and magnitude between Australia and its Ring of Fire neighbors illustrates just how much plate position actually matters. So we've now covered the mechanics, the historical observations, and the current monitoring. But now let's talk about what all this actually means for people living and working on the Ring of Fire. And I'm speaking from experience here. Between 2017 and 2023, I worked as a crabber and as a commercial fisherman in Alaska. I've seen multiple volcanic ash and steam clouds from eruptions while we were out on the water. And in 2018, we were in port when a tsunami warning was issued. We had to evacuate town immediately on our boat, while everyone in town without a boat headed for higher ground. When you're living and working on the Ring of Fire, this isn't theoretical. It's real, and it can happen without warning. Hundreds of millions of people live directly on the Ring of Fire. Tokyo, Los Angeles, Seattle, Lima, Jakarta, Manila, Auckland. These are major population centers on active fault lines and volcanic zones. The infrastructure, emergency response systems, and public awareness in these regions directly affect how communities respond when major events occur. We have clear historical precedent as well. The 2011 Tohoku earthquake and tsunami in Japan killed nearly 20,000 people and triggered the Fukushima nuclear disaster, despite modern engineering and early warning systems. That event demonstrated both the effectiveness of preparation, Japan's building codes and tsunami warning systems did save lives, and the limitations. Some areas still suffered significant damage. Research from the University of Washington on the Cascadia subduction zone shows that it has produced magnitude 9 plus earthquakes roughly every 300 to 600 years for the past 10,000 years. The last one was in 1700, which puts us within the statistical time frame for another event. Current models suggest such an earthquake could cause significant damage and casualties, and coastal areas could see tsunamis within 15 to 30 minutes of the earthquake. Now, building codes in the Pacific Northwest have improved in recent decades, but older infrastructure remains vulnerable. The difference between severe loss and reduced impact often comes down to preparation. Japan's experience shows that building codes, early warning systems, and public education affects outcomes. On the volcanic side, monitoring has improved dramatically. Modern systems can detect precursor earthquakes, ground deformation, and gas emissions that often indicate potential eruptions. However, volcanoes can still behave unpredictably. The 2022 Tonga eruption surprised scientists with its violence. The volcano had been relatively quiet before producing an explosion that was heard thousands of miles away. Understanding these patterns has practical applications. If you live in or visit Ring of Fire regions, awareness of geological hazards should inform your decisions. Having emergency supplies, knowing evacuation routes, understanding tsunami warning signs, and being aware of local building codes are practical applications of this information. The indigenous knowledge that we discussed earlier encoded this kind of practical survival information. When the ground shakes strongly near the coast, when the ocean retreats, move to high ground immediately. That's observed pattern recognition, and it actually saves lives. Modern science gives us more detailed understanding of mechanisms and probabilities. Cultural records give us long-term observations of how these events actually manifest. But both types of information are extremely useful. Alright, let's quickly bring all this together, summary style. The Pacific Ring of Fire exists because of subduction. The Pacific Plate being consumed beneath surrounding plates along a 25,000-mile zone. This produces about 90% of the world's earthquakes and 75% of its volcanoes. Australia escaped this because of its position. It sits on a stable craton in the middle of the Indo-Australian Plate, far from the subduction zones. When it separated from Antarctica and drifted north 45 million years ago, it ended up away from active boundaries. New Zealand, Indonesia, Japan, the Philippines, and the Pacific coastlines sit on those boundaries. Geography determines the geological character. Indigenous observations from the Ring of Fire cultures contain accurate information about earthquake and volcanic patterns. Observations preserved as survival information. Modern geological research has confirmed many of these accounts, from Cascadia megathrust earthquakes to New Zealand volcanic sequences. Historical observation and modern monitoring provide complementary data. Current research shows that while global earthquake frequency appears stable when accounting for improved detection, regional patterns may vary. Volcanic activity continues at rates that have been normal for the Ring of Fire throughout human history. For people living in the Ring of Fire regions, this understanding translates to practical preparation, awareness and planning based on known geological patterns and historical precedent. The Ring of Fire has been active throughout human history. What's actually changing is our ability to monitor it, to understand the mechanisms, and to prepare for future events. And that's where we'll leave the brain train today. If you found this video useful, or if it raised questions that you want to explore further, well, that's what this channel is about. Presenting information, following evidence, and asking questions without worrying about whether conclusions are making people uncomfortable or not. All of the sources are listed in the description or in the pinned comment because I want you to verify what I've said. Check the research, look up the indigenous accounts, examine the geological data yourself. Don't just trust me blindly, investigate for yourself. Finally, if you have any suggestions or if you have topics that you'd like me to cover, let me know in the comments. Subscribe to the channel and help me grow so I can keep making these productions a little bit better each time. And hit that notification bell so you don't miss out on the next ride. I'm Alex Arnold, and this has been Arnie's Brain Train. Stay curious, stay skeptical, and as always, remember, the world isn't always this simple, but it's always this interesting. I'll see you at the next stop. Bye.